Graphing a rational function. I have number 1 here, f of x equal 5 over x minus 2. This particular function would have to find all 5 steps. Number 1, there's not going to be any whole, so there's going to be none. We didn't factor anything, we did not reduce anything. A vertical asymptote, we have to make sure the denominator cannot equal to 0, it creates a vertical asymptote. The horizontal asymptote is going to be the k over here, which is y equal negative 2. The x-intercept, we're going to make y equal to 0, and then we're going to solve for x. 5 over x minus 2 equal to 0. We're going to add 2 to both sides. 5 over x equal to 2. Cross multiply, and you will get x is equal to 5 over 2. The y-intercept, we're going to make x equal to 0. And you know, when you divide by 0, it's impossible. Here is another approach. I want you to take this function here and do a common denominator. So if you have negative 2 over 1, multiply top and bottom by x. This same equation can be rewritten as 5 minus 2x over x. Now if you look at the function f of x equal to, I'm going to rewrite it again as negative 2x plus 5 over x. If you were to look at this function over here, can we go ahead and find all the 5 steps? Is there any hole in the graph? Well, we didn't factor, we didn't reduce, nope. Next, we're going to look for the VA, and as you can see here, the VA is going to be x equal to 0 when we set the denominator equal to 0. The next step will be the HA. HA will be Bobo button eats DC, and as you can see, the exponent on the top, the exponents on the bottom is the same, so we're going to divide the coefficient, and the coefficient is going to be negative 2 over 1 or simply negative 2. The x-intercept is when you set the numerator equal to 0. If you set up negative 2x plus 5 equal to 0, that means x is equal to 5 over 2. And then finally, if you do the y-intercept and then you substitute 0 for x equal to 0, and you will find yourself dividing by 0, which is impossible. Next, what I want you to compare the two strategies that we just did. We did all 5 steps for the first form. We did the 5 steps for the second form. As you can see, the whole stays the same. The vertical asymptote stayed the same. The horizontal is the same. X-intercept were the same, and the y-intercept are the same. Now what we're going to do, we're going to move forward and graph. Okay, we're going to go ahead and graph. The first thing I need you to do is the vertical asymptote at 0. Since the vertical asymptote is at 0, that explains why we have no y-intercept. The horizontal asymptote happened to be at negative 2. And just label here negative 2, this is 0. We do have an x-intercept at 5 over 2, which is 2.5 over here. Alrighty, so now to finish up the graph, I want you to look to the right of the vertical asymptote. You have to start near the asymptote, you have to cross at the x-axis, and you have to end near the asymptote. On this side of the graph, you need to choose or make an educated guess, if you will, and it has to be either the top part or the bottom part, but it can be both. So we're going to choose the bottom part, because if we have to make the choice and go on the top, then we end up crossing the x-axis. The last thing I want you to state here is the domain and the range. And the domain will be everything excluding the vertical asymptote, negative infinity to 0, and then 0 to positive infinity. Okay, the range will be everything excluding the negative 2. So from negative infinity to negative 2, and from negative 2 to positive infinity. This problem is done. Number 2. We are going to graph negative 8 over x minus 3. The first step is there's going to be no whole because we did not factor, we did not reduce. VA is when the denominator equal to 0. If x minus 3 equal to 0, that means x is equal to 3. HA, we're going to look at Bobo button or DC. In this case, it's bigger on the bottom. It's Bobo, so it's y equal to 0. x-intercept is when we make the numerator equal to 0. But as you can see, the numerator in this case is -8. -8 can never ever be 0. That's impossible. That means no x-intercept. The y-intercept, we're going to make x equal to 0. And so the y will equal to -8 divided over 0 minus 3, which is -3, or simply 8 over 3. There is no other form of this function. This is the only way this function can be written. So what we want to do, we want to go ahead and start graphing. And so to graph this function, right over here, I want you to state the asymptote vertical at 3. And this is 3. Horizontal at 0. And as you can see, that will explain why we have no x-intercept. It happened to be the asymptote. The y-intercept is 8 over 3, 2 1/3. 1, 2, right over here, 2/3. That's 8 over 3. Now, if you look at this side of the asymptote, the right side, you have to make a choice, the top or the bottom. But if you were to plug in any number bigger than 3 and plug it into the initial function here, let's say we pick 10. -8 over 10 minus 3. Is the ratio positive or negative? The ratio is going to be -8 over 7 or simply negative. That tells you we're going to go below the x-axis from asymptote to asymptote. On this side of the graph, on the left-hand side of the asymptote, we know we're going to cross the y-axis over here, so I'm not going to make any guess. I'm just going to go ahead and make an educated guess and graph it. Finally, I need you to state the domain and the range. The domain will be excluding the vertical asymptote, which is 3, and all the way 3 to positive infinity. The range, you exclude 0, so -infinity to 0, and then 0 to positive infinity. Then, number 3. I have this rational function over here. There is nothing to factor, nothing to reduce. That means there is no hole in the graph. Vertical asymptote, set your denominator equal to 0, and in this case x is going to equal to -4. Horizontal asymptote, we're going to look at the exponents of x. Since both of them have the same exponents, it's each dc, we're going to go ahead and divide the coefficient. The coefficient is going to be 1 on the top and 2 on the bottom. The x-intercept is when we make the numerator 0. If you go ahead and make x minus 3 equal to 0, that means x equal to 3 is an x-intercept. The y-intercept when we make x equal to 0 and we solve for y. So that means y equal -3 over 8. I want it now, before I go ahead and graph, I want to change this function into the other form. Okay. So now here what we're going to do, we're going to take this function, and in order for us to do syntactic division, I need you to multiply the top by a half and the bottom by a half. Because syntactic division can be only applied if the denominator is in the form of x plus or minus a number. If you were to multiply the top, you will have 1/2 x minus 3 over 2. If you multiply a half on the denominator, it will be x plus 4. Now, we're taking this form here and doing syntactic division. That means we're going to put -4 in the corner, and the numerator, we put the coefficient of x here, which is a half. We put the constant term here, which is -3 over 2. Syntactic division is you drop the 1/2 below the line. You multiply -4 by 1/2 and you will get -2. And you add -2 minus 3/2 is going to be -7 over 2. This is going to be the remainder. So the way we're going to rewrite this function is y equal 1/2 minus 7 over 2 divided by x plus 4. Now we can also rewrite this one here to simplify it a little more. We have y equal -7 over 2 times x plus 4 plus 1/2. I want you to take that form and look at that form only and do all 5 steps. Okay, we did not factor, we did not reduce, there will be no whole. VA, we're still going to look over here and say what makes the denominator equal to 0, and it's going to be x equal -4. HA is going to be the K, the horizontal translation, so that will give you y equal to 1/2. The x-intercept, we're going to make y equal to 0, we're going to solve for x. So if I have this equation, -7/2 times x plus 4 plus 1/2 equal to 0. Go ahead and subtract 1/2 from both sides and cross multiply. So 2 times x plus 4 equal to -14. Divide by -2. You will end up with x plus 4 equal to +7. Subtract 4x equal to 3. As for the y-intercept, the y-intercept is going to be making x equal to 0. And if x is equal to 0, y is equal -7/2 times 0 plus 4 plus 1/2. This will give us -7/8 plus 1/2. 1/2 is the same thing as 4/8, which gives you -3/8. We have everything we need. Next, we're going to go ahead and graph. So I found all 5 steps on both forms of the same equation. Okay, graphing this function, we have a vertical asymptote at -4, and so it's going to be over here. That's -4. We have a horizontal at +1/2. We have to cross the x-axis at 3. We have to cross the y-axis at -3/8. So as you can see on the right side of the asymptote, we have to choose the bottom part from this asymptote, crossing here and crossing the x-intercept and the y-intercept and ending near the asymptote. On this side of the graph, you have to be choosing the top or the bottom. By choosing an educated guess, I want you to choose the top, because if you choose the bottom, you end up crossing the x-axis, which is not allowed. Next, what we're going to do is finish up the problem by finding the domain and the range. So the domain of this function is everything excluding -4, -infinity to -4, and -4 to +infinity. The range will be from -infinity to 1/2 and from 1/2 to +infinity. Done.